In this video, I'm going to talk a little bit more about soldering, and we're going to go through the steps and some of the important information regarding soldering. Remember, soldering is joining two pieces of tubing or pipe together using a filler metal known as solder. Okay, it's the most common method of joining copper pipe and tubing in hydronic heating systems. It uses a 95-5 solder, so 95% tin, 5% antimony solder. The maximum working pressure rating for 95-5 solder is 300 psi. Solder used to be used very heavily on the suction side of refrigeration and air conditioning systems, but with the new refrigerants, we cannot guarantee we are going to be under 300 psi. So it's no longer used. We use braze instead. But solder maximum pressure is approximately 300 psi for 95-5 solder. Okay, the alloy content of all solders are listed on every roll of solder. Okay, look at the label. It's listed on the solder roll. The melting range for 95-5 solder is about 452 degrees to 464 degrees. This narrow melting range also means that the joint will solidify very quickly when the heat is removed. In other words, there's a fine balance of heating is needed when soldering. Proper soldering results in a very clean, neat, and watertight joints. Sloppy joints, even if they're watertight, are indicators of poor craftsmanship. With a little practice, making good solder joints will become second nature. Okay, this is an example of someone soldering. So step-by-step procedure to solder, and you're going to practice this in the shops. Step 1, be sure that the tube is cut square. Use a wheel cutter. Avoid using hacksaw whenever possible. Step 2, remove any burrs. Ream the end of the tube with the blade of the cutting wheel, a round file, or some other type of deburring tool. Okay, we can't have any slivers of metal on the end of it. It needs to be clean. Okay, this is an example of wheel cutter and the deburring tool. So again, you cut the pipe with the wheel and then use the deburring tool to clean out the end. Step 3, assemble the joint and check it for proper fits and alignments. In most cases, there's going to be no problems with the fit. However, sometimes the fitting may be damaged or defective. Check this before you go further. If the fitting wobbles noticeably on the pipe, it should be replaced. It's not going to solder properly. Clean the socket of the fitting with a properly sized fitting brush. Be sure to remove any pieces of the steel brush bristles remaining in the fitting after cleaning. These small pieces of steel can create galvanic corrosion that could eventually cause a leak in the fitting. When cleaning a large number of fittings, a cleaning brush can be adapted to fit the chuck of a cordless drill. Okay, this is an example of a hand cleaning brush, and the cleaning brush, by cutting the handle off of it, can be adapted to fit in a drill if you're doing a ton of fittings. Clean the outside of the pipe with an emery cloth. Okay, all oxidation, scale, dirt, or paint and oil should be removed from the tubing at least ½ inch further back than the edge of the fitting socket. When the tube appears to be bright following cleaning, okay, be sure to clean all the way around the perimeter of the pipe. Don't do just one side. It matters. So again, you're going to use the outside and clean it with an emery cloth. 120 grit is what we normally use. Step 6, apply paste flux to the fitting socket and the portion of the pipe that fits inside the socket. The flux chemically cleans the surface of the socket and helps prevent oxidation of the surfaces when heat is applied. Always use a flux brush, not your fingers, to apply the flux. Do not apply excessive amounts of flux. Only a thin film is needed. After fluxing, slide the tube into the fitting, and whenever possible, rotate the fitting once or twice to further spread the flux. Finally, clean the excess flux off with a clean rag prior to applying heat. Okay, so you're going to apply the flux. Okay, don't get this on your hands. Okay, it can actually cause some your hands to burn, break out, and stuff like that. It's an acidic material. Okay, so use a flux brush and try to wear gloves if at all possible. Step 7, apply the heat to the outside of the fitting socket using a torch. Keep the blue tip of the flame just above the surface of the socket. Move the torch tip around the fitting to promote even heating. You don't just want to heat it in one place. The metal will weaken, expand, and contract all in one place, and you don't want that to happen. So you're going to apply the heat to the fitting, but again, go all the way around the fittings. Heating times differ considerably with the type of torch, gas being used, as well as the pipe size, ambient temperature, and types of solder. When the flux begins to sizzle or turn very clear, test the joint by applying the tip of solder to the edge of the joint. If it sticks but does not melt, apply more heat. If the solder immediately melts, the joint is ready to draw on the molten solder by capillary action. Once the solder begins to flow, it can be continually fed into the joint. Only a small amount of solder is needed. An experienced pipe fitter knows by sight how much solder to feed into a joint. An inexperienced person often feeds excessive solder into the joint. It just takes practice. The excessive solder can solidify into small loose particles inside the pipe. These can be carried around a system by fast-moving fluid and become lodged in various valves or circulators. A good rule of thumb is to use approximately the length of solder that is equal to the diameter of the pipe. In other words, if you have a half-inch diameter pipe, you're only going to use a half-inch of solder. Okay, good rule of thumb. It seems to work every time. After the solder is applied, remove the torch, and if necessary, carefully wipe the perimeter of the joint with a clean cloth to remove excess solder or flux. The joint should be allowed to cool naturally before being handled or stressed. Don't dump water over it. Let it cool naturally. Okay, solder is unlike braze or some of the other ways of putting pipe together. It has to cool naturally. After the joint has cooled, one last wipe of a pipe with damp rag will remove any remaining flux. This is an important step because flux residue left on a joint eventually causes unsightly surface oxidization. Okay, the pipes will turn green and other colors where flux is left. Be a professional. Always clean all the joints. It is best to create piping assemblies on a horizontal working surface. The solder flow is more controllable. When soldering has to take place next to a combustible material, place a non-combustible material such as sheet metal between the torch and the material you're protecting. Measure all tubing carefully before cutting. Allow for the amount of pipe that will fit into the fitting socket. Okay, don't just measure from the tip of the socket. Think about it. You might have a half-inch of pipe into the fitting socket. Take that into account. Whenever possible, attempt to keep all piping plumb. That's vertically and horizontally in a straight line. Install temporary piping support if you need to hold the pipe in proper alignment for soldering. When soldering valves, open the valve to allow the heat to exit so no valve damage occurs. This is especially true for zone valves. Always read the installation instructions from the valve manufacturer. And speaking of valves, if it has an electronic head on it, in other words, a motor or something, or actuator to open and close the valve, remove that before you solder. On fittings that have both soldered and threaded, assemble the soldered joint first. This prevents discoloration or burning of the Teflon tape or joint compound used during soldering. Always keep one end of the pipe open while soldering. If this is not done, pressure can build up in the pipe due to heat and cause pinholes to form in the solder. Finally, take a few extra minutes to clean up excessive flux and solder. Your customer will notice it. You can have the best solder joints ever. If you don't go back and clean those pipes, this customer will notice it. Okay? And don't know where that came up, but it is what it is. Okay, so soldering, again, practice does make perfect.